The first video in this series was meant to walk you through the card sort, which takes you from number 1 to number 20 on page 2 of our new packet. And once you finish the card sort, the goal is to complete questions 21 through 25 with observations that you made about the patterns that you saw and the way that you figured out what was going on in order to successfully match up the cards. Hopefully throughout the card sort you were thinking about and noticing some of the differences among the cards themselves. Both the obvious differences, like, oh, this green card has a table versus this one has a graph, and differences among their equations. Some of the equations you probably noticed had a plus or a minus sign, where other equations had a multiplication. Some of the multiplications had a fraction, some of the multiplications had a whole number. And you may have also picked up on differences in structure about the equations themselves. Some equations had an exponent with a variable n, and in other equations there was no exponent. So in order to complete questions 21 through 25, you may want to consider having the Desmos screen open again, so that way you can make some observations based on things that you can see. Now, in terms of new vocabulary, I just want to highlight a couple of things in numbers 21 through 25 that you should be aware of, just so that way you can start building this mathematical vocabulary yourself. In number 21, it says on the packet page, all of the sequence cards with adding or subtracting patterns are called arithmetic sequences. And you're going to see that phrase used pretty liberally throughout this packet. So you may want to get used to that phrasing. Arithmetic sequences are basically any sequence or pattern that has either an adding or a subtracting pattern to it, which means that if you had a card, for example, like the one that talked about having a certain number of something to start and then adding 3 each time you go, adding 3 is an example of an arithmetic pattern because you're adding something. Phrasing that also suggests subtracting would also be lumped into the same category of arithmetic. So arithmetic, not coincidentally, is spelled the exact same way as the word arithmetic, though pronounced a little differently, and it's because they come from the same root idea. Arithmetic refers to the arithmetic of adding, and since subtracting is just adding negative numbers, you can see why that logic kind of holds up. In question number 22, you'll learn a similar vocabulary term for multiplying and dividing patterns. That's called a geometric pattern or a geometric sequence. So multiplying and dividing are collectively referred to by one single term as well. And again, the logic is kind of similar. The multiplication aspect of a geometric sequence is really no different when you're talking about division. Division is just multiplying by fractions. So that's why when you're looking at these two families of sequences, arithmetic versus geometric, you can really think of the major operations as being lumped together. Adding and subtracting is collectively called arithmetic, and multiplying and dividing are collectively called geometric. There was a third kind of a third category that you didn't really find as many patterns for, and that was the quadratic sequences. Hopefully that word quadratic sounds familiar because quadratic formula and quadratic equation both refer to the idea of something with a square. So anything that you saw with a square was a quadratic sequence. And you should have found, if I remember correctly, 3 patterns that were quadratic in nature. The fourth and final possibility was that there was a single sequence that didn't appear to be truly arithmetic, truly geometric, or quadratic. And that remaining sequence, hopefully you narrowed down because it would have been the only one that you didn't list in number 21, 22, or 23. It actually is a really famous sequence, and if you want to Google it or do a little bit more further study, especially now that we have all kinds of time for this sort of thing, it's called the Fibonacci sequence. Fibonacci is a fairly famous mathematician, and his sequence is actually really well known for a lot of patterns that are kind of cool just in a self-contained way, but also cool because they have a ton of real life applications. So we'll actually talk about the Fibonacci sequence at some point in a follow-up video, but for now, if you want to do a bit of self-study, the Fibonacci sequence is the one that is not arithmetic, not geometric, and not quadratic. It's sort of in a classification all of its own, but it's a fascinating sequence, and its applications in real life are actually fascinating because of how many truly random seeming things are actually not random. They're actually Fibonacci patterns. So in any case, once you've got this vocabulary now, the goal is to go through back into the Desmos activity, see if you can identify which sequences by letter were the arithmetic ones, and be as specific as you can about what you notice about their equations. In 22, identify all the geometric sequences and try to make some general comments about their equations. And when I say general comments, I'm referring to things like, what do the equations look like? What sort of punctuation do they have? What sort of structure do they have? Do they have parentheses? No parentheses? Do they have an exponent or no exponent? Things that you can do to classify and differentiate these two main groups are definitely helpful here. The quadratic sequences we're not really going to focus on as much, which is why you don't really have to do a whole lot of analysis with quadratic sequences. But if you want to make any mental notes to yourself about things that you notice about quadratic sequences, that's great too. The last task in this little chunk of problems through 25 is to see if you can identify information that helps you better understand the initial value. The initial value is what we kind of consider a starting number. You can tell somebody that there's a pattern to something. For example, I can say to you that I'm thinking of a pattern that involves adding 10. But if I don't tell you what number I'm starting with, you really can't think of the sequence of numbers that I have in mind. And let's use this as a perfect example. Think, if you can right now, about a sequence of numbers that involves adding 10. And just picture a few numbers in your head. I'll give you a few seconds to picture those numbers for yourself. And then I'll show you the sequence that I was thinking of. And you'll have to tell me if this was the sequence that you kind of figured out on your own. I'll give you a few seconds. Okay, those were my numbers. Are those the numbers you thought of? Because if not, then you can see the importance of a starting number. If I told you that I was starting with the number 17 and then adding 10, you probably would have figured out my numbers very quickly. But without me saying where I started, adding 10 could mean anything. Adding 10 could be an infinite series of random numbers that you could start with, and we would never be on the same page. So you can tell why the initial value is important. And in these questions, it's going to ask you to go back to the green cards and to look at how you know where the equation's initial value is. If you're looking at a table, if you're looking at a graph, if you're looking at a list of numbers, or if you're looking at a word problem. So all of these questions refer again to the green cards in the Desmos activity, and you'll be able to go through those green cards, hopefully with a little bit of information now, and to say to yourself, okay, wait, every time it's a table, here's where I can find the initial value. Or every time I see a list of numbers, here's where I can find the initial value. So this should be a good way of sort of summarizing where to look for an initial value, no matter what kind of sequence problem you're being given. So by the end of this video, you should have gotten the main ideas for numbers 21 through 25. And before you start the next video, complete these questions and check your answers using the link provided on the learning plan. Once you feel like you have a pretty solid idea of what an arithmetic sequence is, what a geometric sequence is, and what a quadratic sequence is, then you'll be ready to do number 26. The next video in this playlist will talk specifically about the math behind number 26. But as always, you don't have to watch the video. If you feel like you get the hang of it, you're certainly welcome to do and finish number 26 on your own. Wednesday's task on the learning plan is to simply finish this page, and Thursday's task will be page 3. Although they're very much connected, I don't necessarily need you to overwhelm yourself. I'm trying to keep each of these tasks limited to roughly as long as they would take if we were in class together. So if you want to work ahead to page 3 today, you're certainly welcome to do it. Otherwise, consider page 3 to be a next day activity. Once you've let the idea on page 2 marinate, once the card sort makes sense, then page 3 can be an additional follow-up activity. But if you've got some momentum, you feel like you do understand, and you feel like you want to keep going, certainly feel free to move on to page 3 and watch the follow-up videos in this playlist if you need more information about how to complete the questions.